Ladies and gentlemen, thank you for attending to this historical session where I will try to do a comparison between Galileo Ferraris and Nikola Tesla from the scientific and a little bit from the human point of view. I think that the best way to start this comparison is to start with the famous question, and the question is who discovered the rotating magnetic field and the induction motor? You are all experts in electrical machine and drive. You know that till now this question is still open, even if the answer is well defined. So for who is interested in this history, my suggestion is to start from a very interesting, very detailed analysis of the history of the rotating magnetic field and the induction motor, using this paper by Ronald Klein. He is a historian of IEEE, and he worked for the IEEE Center for History and Electrical Engineering. I met for the first time Ronald Klein during the conference we had here in 1986, organized by Professor Paolo Ferraris for 100 of the discovery of the electrical machine and drive, the induction motor here in Torino, where he presented another interesting paper on Galileo Ferraris. So starting from the paper by Klein, it's possible to find the first idea of the rotating magnetic field based on the study by Arago, and this system is known as Arago rotation, where a copper disk with a magnet suspended over the disk. If you put in rotation the disk, the magnet starts to rotate in the same direction of the disk. Obviously, that is also right the inverse. So if you put in rotation the permanent magnet, the disk would follow the disk. But we have to move until the end of the 19th century before you can find the first prototype and the first theory of the induction motor and the rotating magnetic field. And in the paper of Ronald Klein, we can find that in 1888, the paper on motor, Ferraris used the Faraday explanation of the Arago's rotation in basic definition of the energy loss output power to formulate a mathematical theory for the first induction motor. And here you can see the first prototype by Galileo Ferraris. You can see the model downstairs in our exhibition with other two models. And this is the last one in 1886. It's well evident that in some way it's difficult to say that this is an induction motor because it is very rudimental. In this case, we have two coils, no iron lamination. The rotor is just a cylinder made by copper, and the cylinder is suspended by a cotton wire. Supplying this model with a two-phase machine, Galileo Ferraris discovered that the cylinder started to rotate. And in the same years, we have the first model of, we can call an industrial induction motor. Again, from the paper, we can read that this motor worked at the same principle as the one Galileo Ferraris built, but, and this is obviously right, Tesla motor was more powerful and efficiency because its secondary winding provided a better path for the eddy current. In this case, it's well evident that we have the stator lamination, the rotor lamination, and like the prototype built by Galileo Ferraris, the motor is a two-phase motor in the stator and in the rotor. Okay, if we start to compare the two figures, I think that it is interesting to start with a chronological event in the life of Galileo Ferraris and Nikola Tesla. Galileo Ferraris was born in 1847 in Livorno Vercellese, now is Livorno Ferraris, close by Torino. I think that there are 40, 50 kilometers from Torino. Now the name is exactly Livorno Ferraris. And Nikola Tesla was born in 1856 in Smiljan in Croatia. Now, I don't want to discuss if Croatia or Serbia, but now we are in that age, not in the geography condition we have now. Nikola Tesla was 9 years younger than Galileo Ferraris. In 1969, Galileo Ferraris got the master's degree in civil engineering because the electrical engineering was not active in that time at the Application School for Engineering in Torino. And in 1870, he was assistant of professor assistant in the Royal Museum in Torino, that now is the Politecnico of Torino. In the same age, Nikola Tesla studied engineering and physics, but without receiving the degree. So from this table, it's well evident the main difference between Galileo Ferraris and Nikola Tesla because they have a different scientific and technical approach to the physical problem. Galileo Ferraris was an academic figure, and he always had an academic approach to the problem solution. Nikola Tesla was a practical but very creative person, focused on finding technical solution to his idea. Okay, in 1879, Professor Galileo Ferraris was a full professor in the Technical and Physics Royal Museum in Torino, and in 1881, Nikola Tesla started to work for the Budapest telephone exchange. 1 year after, he worked for the Société Électrique d'Yonne division in Ivry-sur-Seine, suburb of Paris, installing the light system. And in 1984, he emigrated to the United States and started to work for the Edison Machine Works, a manufacturing division in New York City for 6 months. So while Galileo Ferraris got the full profession position, Nikola Tesla started to work in electrical engineering and emigrate in USA, working for the Edison company. Next slide, we have in 1985, we are close to the critical years. In May and June, he discovered the rotating magnetic field and built the first prototype of the induction motor you saw in the previous slide, and this is confirmed by the client document at page 706. In the same time, Nikola Tesla met two businessmen, Robert Lane and Benjamin Vail, who agreed to finance an arc light manufacturing and utility company with the Tesla name, and it was the Tesla Electric Light Manufacturing Company. 1 year after, the same businessmen formed a new utility company, abandoning Tesla company and leaving the inventor penniless, so no money for his invention. Tesla haven't lost control of the patents, and he had degenerated since he had assigned them to the company in exchange of stock. In the late of 86, Tesla and Alfred Brown and the Western Union superintendent formed the Tesla Electric Company in April 87, with an agreement that the profit of the company was divided 1/3 to Tesla, 1/3 to Peck and Brown, and 1/3 to fund the development of the Nikola Tesla idea. In 87, he developed an induction motor that ran on alternated current. The motor used polyphase current, which generated a rotating magnetic field to turn the motor. This is the principle that Tesla claimed to have conceived in 82, so before Galileo Ferraris. So the conclusion that in this year, the Nikola Tesla business spirit rises, but not without some problem, as is evident here. In 88, this is the critical year, Galileo Ferraris presented the paper Rotazioni elettrodinamiche prodotte per mezzo di correnti alternate, and the paper is in the proceeding of the Science Academy of Torino, and he discussed the paper in a meeting on 18 March 88. Nikola Tesla, in the same year, patented the induction motor by the Westinghouse company. In 91, George Westinghouse explained his financial difficulty of his company to Tesla, saying that if it did not meet the demand of his lender, he is Westinghouse, would no longer be in control of the Westinghouse Electric, and Tesla would have to deal with the banker in order to collect the future royalties. So Tesla agreed to release the company from the royalty payment clause signed in the contract. On 30 July, at the age of 35, Tesla became a naturalized citizen of the United States. In 92, Galileo Ferraris got the commander title from the Royal Crown of Prussia for the discovery of the rotating magnetic field. This is the first step about a controversy between the world divided in two parts. Europe was from the side of Galileo Ferraris, in particular Germany and France, and obviously USA and the UK was on the side of Galileo Ferraris, and that it is the first step in that direction. 93 is an important date both for Galileo Ferraris and Nikola Tesla, because Galileo Ferraris was the Italian delegate in the International Electrical Congress in Chicago. This is a very important point. And this is just a summarize. I will discuss in detail in the future slides. The Congress delegate accepted his proposal for the definition of watt, joule, and Henry. In particular, it's very important the point about the definition of the inductance in Henry unit. From the side of Nikola Tesla, Westinghouse Electric asked to Tesla to participate to the the Chicago exposition, where the company had a large space in the electricity building devoted to the electrical exhibition of the product produced. And in particular, a special space was set up to display various form and model of the Tesla induction motor. Another important point is that in the same year, the Niagara Falls Cataract Construction Company awarded a contract with the Westinghouse for building the famous power station, a two-phase AC generating system in the Niagara Falls, based on the Tesla advised Westinghouse demonstration in the Columbia in Chicago exposition. And in '94, we have the second important paper by Galileo Ferraris, Metodo per la trattazione dei vettori rotanti alternativi. This paper will be published also in English on the journal Electrician and translated in another journal in French. In '95, this is an interesting point, the German company AEG appealed against the company Helios, dealer of the Tesla patent, that disputing the discovery of the rotating magnetic field of Tesla. And from the Nikola Tesla side, Edward Dean Adams agreed to help found the Nikola Tesla company that was in economic difficulty to found, develop, and market a variety of previous Tesla patent and invention. And Alfred Brown signed it on, bringing along patent developed under Peck and Brown, and the company handled the Tesla patent for several decades. Okay. In '96, Galileo Ferraris founded the AEI, Italian Electrotechnical Association, is still alive now, and he was acclaimed the first president. In '97, Galileo Ferraris was elected as a senator of the Italian kingdom. And in the same year, Westinghouse purchased the Tesla patent for a lump sum payment of $16,000, sharing the patent with the General Electric. On 7 February, Galileo Ferraris passed away for pneumonia, and the next year, the lawsuit between AEG and Helios is closed, and the judgment recognized Galileo Ferraris as the discoverer of the polyphase current. Now we have to move until 1943, because in the 7th January, at the age of 86, Tesla died completely alone in the room 3327 in the Hotel New Yorker in New York. So with that, we can close the comparison from the chronological point of view. And now I think that can be interested to compare Galileo Ferraris and Nikola Tesla also from some let me say, gossip, if we wanted to call in this way, from the personal life and character. I think that in all the biography of Galileo Ferraris it's possible to find these 2 points, because during a meeting, Galileo Ferrari stated that in Frankfurt, where he was for an electrical exposition, said, in Frankfurt, I saw that everybody assigned me the first idea, and that is sufficient. The other can get money, but for me, the name is sufficient. This is, I think, an important statement that can frame the figure of Galileo Ferraris. And again, in all the bio, you can read that during the last lecture with his student, due to a high fever, he stopped the lecture saying to his student, gentlemen, the machine is broken and I cannot continue. He passed away for a pneumonia on February 7, 1997. What about Nikola Tesla? Again, in the bio, you can read that Tesla read many works, memorizing complete books, thanks a photographic memory, was in a very extraordinary person. He was a polyglot person, speaking 8 languages: Serbo-Croatian, Czech, English, French, German, Hungarian, Italian, and Latin. And another characteristic of Tesla is that he visualized an invention in his mind with extreme precision, including all the dimensions, before moving to the construction stage, and he typically did not make a drawing by hand, but worked from his memory. Okay, so he's really a very incredible person. And as I said before, Tesla died alone in a room of a hotel in completely poverty. Okay, now we can continue the comparison using the fact behind Galileo Ferraris and Nikola Tesla. And here we have the first important fact is the paper. This is the first page, and this is the translation in English: electrodynamic rotation by means of alternate current. And here we can find important point about the theory of the polyphase current and the induction motor. In particular, it's possible to find the introduction to the phasor concept we use when we teach the electrical machine. Here you can see the figure representing his model of the induction motor and the demonstration of the rotating magnetic field, and this is the model I discussed before. In other part of the paper, it is interesting that if introduced the concept of the absolute slip, I mean the difference between the rotating magnetic field speed and the rotor mechanical speed, and in particular he found the relation between the ratio between the mechanical power and the mechanical power plus the losses, and this ratio is exactly, when we know, the ratio between the mechanical speed and the speed of the rotating magnetic field. In another part here, Galileo Ferraris tried to find the maximum efficiency of the induction motor, and probably this was a big mistake of Galileo Ferraris, because starting from the mathematical definition, computation of the maximum efficiency, using the data he has in his hand with the prototype, he did a demonstration that the maximum efficiency is equal to 0.5 when the mechanical speed is 1/2 of the speed of the rotating of the magnetic rotating field. And his conclusion is here in Italian, but the translation is here. Since the efficiency is equal to 0.5, the system cannot have any interest in industrial applications. So it's absolutely a wrong consideration. This is the second paper, a method for the rotating vectors and application to the alternate current electrical motor. And here we are in our field. look, probably here we can find the first electromechanical characteristic torque speed, because U is the frequency of the relative motion between rotating magnetic field and rotor, and this is the well-known torque characteristic we teach to our student. So it's well evident the starting torque, the peak torque, and the torque equal to 0 when the rotor is in synchronous condition. And, oh, sorry, I forgot to. And in this equation, K is the torque. In this equation, Galileo Ferraris demonstrated that the torque is depending on the slip, okay, and in particular on the denominator, we have the number of turns, the flux density squared, the section square, and the ratio, and behind this denominator we have the square of the electromotive force. So Galileo Ferraris discovered that the mechanical characteristic, the torque, is depending on the square of the voltage. Okay, here, this is, I think, a very interesting point, because Galileo Ferraris analyzed also the real single-phase motor, and is well evident here that he did the analysis like we teach to our student, where we have the torque produced by the rotating magnetic field rotating in the clockwise direction, and the torque produced by the rotating magnetic field in counterclockwise, and doing the difference between the two mechanical characteristics, is possible to find exactly the torque characteristic of a single-phase motor, where the starting torque is equal to 0, and again the torque is 0 not in synchronous condition, but when for a speed a little bit lower than the synchronous condition. What about the fact for Nikola Tesla? Obviously that the main fact is the patent. To be honest, I discovered that it is completely wrong to talk about the patent, because the patent are two. Because in the same date, May 1, 1888, Nikola Tesla presented two patents with this number and this number. So now we can look to the patents. In the first patent, I will show you only the figure. Here, Nikola Tesla tried to demonstrate the presence of the rotating magnetic field with a written description of the phenomena. In my analysis, not very deep, but anyway, it's not possible to find one equation written by Nikola Tesla. Probably my approach is academic, but really Nikola Tesla didn't write one mathematical equation. And from the motor point of view, in this patent we can find 1, 2, 3, 4, 5 motors. What about the motors in this patent? This is the first one, where we have a stator with a two-phase winding, and the rotor is an anisotropic rotor. So it's not true that in this patent now there is the induction motor, but we can say that Nikola Tesla invented what we know as a reluctance motor. Now we know as a synchronous reluctance motor, because this is the shape with the anisotropy of the rotor. And in the patent, it's possible to read that the rotor can rotate also if the rotor has a cylindrical form. But it's not possible to find any justification in the patent, even if the effect of the eddy current inside the rotor was well known. In this case, we have the second motor, and in this case, the field is produced by the stator, and the rotor, two-phase rotor, is applied. And it is interesting that in the patent, Nikola Tesla wrote that, it is right, the rotor will rotate in the opposite direction with respect to the field in the stator. Here we have the motor 3. In this case, again, the rotor is anisotropic, but the stator is a three-phase machine. In all the figure, on the left, there is the motor, and on the right there is the generator used to supply the motor. Here in the motor 4, again, we have an anisotropic rotor, but the shape is a disc, so in some way is invented also the disc electrical machine. And finally, in the motor 5, here we have a rotor with two orthogonal winding and a stator used to supply the rotor. And again, here is not very clear the idea of the induction motor. But we have to move to the second patent in order to find what we can consider the real induction motor, because we have here a stator, a two-phase stator, and a two-phase rotor with two orthogonal coils. So, to be honest, the induction motor is inside the second patent, and the last motor in the second patent is this one, where we have two orthogonal coil or winding in the stator, but the rotor, let me say, is a sort of cage induction, cage rotor, because it's realized using copper sheets separated by insulation. So this is not the well-known cage rotor, but we can consider this one a rudimental cage rotor. Okay, so this is just a consideration I said before, so pay attention that the patents are two and not only one, and the idea and the definition of the induction motor is for sure in the second patent. In the other one, it is correct to say that Nikola Tesla discovered the synchronous reluctance machine. Okay, now we can move to the subsequent event after the facts I analyzed before, and I used several articles I found in the electrical world. The electrical world may be equivalent to our magazine printed by the Society of our IEEE, and in the June 9, 1988, the same year of the paper and the patent of Nikola Tesla, we can read that Professor Ferraris of Turin, who has been, as will be remembered, was one of the first to make a strictly scientific investigation of transformer. I will not analyze here, but Galileo Ferraris analyzed it in a deep way the transformer and proposed the model of the transformer. In particular, he introduced the concept of leakage flux and consequently the leakage inductance, and who has since then continued to devote attention in alternating current, has just publishes the result of some experiment made with a view to produce a continual rotation of the means. So here we can see the picture I described it in the previous slide. The paper of Galileo Ferraris was published in the Electrician in November and May 88, and the translation in France was published in La Lumière Électrique, another journal of that time dealing with the electrical engineering. And now here we can find the first spark between Nikola Tesla and Galileo Ferraris, because this is an article written by Nikola Tesla, and he writes that, moreover, I did not think it probably, considering the novelty of the idea, that anybody else would be like to pursue work in the same direction. By one of the most curious coincidences, however, Professor Ferrari not only came independently to the same theoretical results, but in a manner identical almost to the smaller detail. And here, Nikola Tesla writes that he is able, as Professor Ferrari omitted to mention various other ways of accomplish similar results, some of which have later been indicated by Schallenberg, who sometime before the publication of the result obtained by Professor Ferrari and myself had utilized the principle in the construction of his now well-known alternate current meter. So if we move this sentence in our day, we are used to say, okay, I write the paper, but you didn't did the citation of my paper. So 150 years before, there is the problem linked to the citation. Now, in that time, we didn't have the AKH index, but the problem is more or less the same. What about the electrician? In 91, we can read that Professor Ferraris in March 1888 was first to make public the principle of this alternating current motor, the development of which now seems like to cause the revolution both in long-distance transmission work and in the distribution of the electrical energy for small motor. And here there is the description of the two-phase rotating magnetic field, and in this case again we find the Arago rotating disk. In the electrician in 91, also we can read this interesting article where at the present moment Professor Ferraris and Nikola Tesla, or rather their respective advocates in the technical press, are contending as the priority in discovering the principle and probably the question which is being ventilated with a great ardor on the continent. If Bradley D'Olivo from Dobrowolski, this is an important researcher, was the first to apply in a practical manner the principle first clearly enunciated by Professor Ferrari and developed for the first time by a route motor made by Nikola Tesla. Okay, this is an interesting point because other important figure in our tale is involved, but here we are, I think, in front of the first fake news, because in any biography you can find that Galileo Ferraris involved and advocated to defend his position. So this is absolutely a wrong point. And this is another point, interest point in the electrical world. Again, we find Dobrowolski. In justice to Dobrowolski, it ought to be said that if Tesla did not publish his research other than his patent, this confirms what I said. Nikola Tesla didn't write any mathematical equation. Dobrowolski ought to have the credit at least for what he did that was not included in the Tesla patent. Dobrowolski thought he may have been an independent inventor, admit that Tesla's work is priority to his Dobrowolski, but he claimed to have improvement. What means behind this sentence? That Tesla was obsessed by the patent, so every time a researcher did an improve of the induction motor, he claimed that the motor was inside the patent by Nikola Tesla. This is an absurd position because, okay, like is right here, Nikola Tesla had the patent of the first industrial induction motor, but other researchers did a very important improvement to the original idea, and in particular, we see that Dobrowolski was a very important figure. Again, here we can read that regarding the subject of priority, it may be of interest here to say that in a conversation, Professor Ferraris last summer, that gentleman told me with very becoming modesty that although he had experimented with the rotary field several years before Tesla's work was published, he did not think it was possible that Tesla could have known of his work, and he therefore believed that Tesla invented it in an independent way. And Galileo Ferraris admit that he also stated that Tesla developed it much farther than Galileo Ferraris did. This is right, because if we compare the model of Galileo Ferraris and the induction motor by Nikola Tesla, it's well evident the improvement of the motor by Nikola Tesla with respect to the model of Galileo Ferraris. And now we can move to probably the most important subsequent event. It is the International Congress in Chicago, and this is the first page where we can see the father of the electrical engineering. This is the main page. We find Galileo Ferraris, Mascard, Roland, and von Helmholtz. And this is the famous picture where all the father of the electrical engineer are together. Here we have Galileo Ferraris. Here we have Siemens, of the Siemens company. And we have Ayrton here, Roland here, and Mascard, and all von Helmholtz. Okay, and we have to pay attention to Car R because I will deal with an important article published by this science. Okay, here that is the confirmation of what I said, because the official delegates contain some of the most prominent work in electrical field in the world, including Helmholtz, Mascaro, Roland, and our Galileo Ferraris. Here there is a short bio of Galileo Ferraris, and in this article is well evident as Ferraris is linked to the rotating magnetic field, and here we can see the paper on the difference of phase in current. So the paper of Galileo Ferraris was well known at that time. And this is not linked directly to the comparison between Nikola Tesla and Galileo Ferraris, but probably is linked to our conference, because in that year, we can read that at 10 o'clock on Tuesday morning, the deliberation of the Congress probably began to facilitate the business work of the Congress, was divided into sections, our session in our conference. In addition to the Chamber of Delegates, consists of the official delegate from the different nations. More or less is the board of the Congress. And look that on Tuesday, the section was called in order at 10 o'clock. Roland and proceeded to permanent organization. The officer elected chairman, Professor Roland, and vice chair, Professor Galileo Ferraris. Look that in this article, you can find Steinmetz, that we know very well for the model of the iron losses and the Steinmetz coefficients used for modeling the hysteresis losses. And I used here the obituary written by Carhart when Galileo Ferrari passed away. Look at the date, is 27 February 1997, because from my point of view, what he wrote is well frame the Galileo Ferraris figure, because we can read that a committee representing some of the most distinguished members of the chamber from different nations has been appointed to formulate the definition of the unit of inductance, the Henry. This committee had met and had failed to write a definition which was satisfactory to anyone. Two forms were reported, and after a few minutes discussion, Professor Ferrari suggested a change in one of them, or no more than 2 or 3 words, which put the definition in the final form in which it now stands. It was at once apparent that this man, Galileo Ferraris, who spoke English with much difficulty and hesitation, has formulated in foreign tongue a definition which his English-speaking congressman has decided to do in vain. So for me, this is really a definition of the figure of Galileo Ferraris from the international point of view. What about Nikola Tesla in the Chicago exposition? Nikola Tesla was present in Chicago, but he was working with Westinghouse. He was invited to a lecture, but Mr. Tesla, after philosophizing for a short time in his usual graceful and pleasant manner, said that he recently become interested in a new field of work, which was, however, rather to development of a certain part of his former high-frequency investigation. So in Chicago, Nikola Tesla didn't speak about the induction motor or the rotating magnetic field, but in that time he was interested on the high-frequency electrical oscillation. Okay, now I am going to close the presentation. What about the answer to our original question, who invented the rotating magnetic field and the induction motor? And we can have several answers, only in the article move in the same direction. In the electrician in 91, we can read that we think that everyone who has followed the history of this, the latest development of alternate current, will be of opinion that there never was a clear case of independent and simultaneous discovery of the same things. If Professor Ferrari enunciated the principle more clearly, Mr. Nikola Tesla gave a more practical turn to the motor, and the name of Ferraris and Tesla should be linked together in honorable union in history. So this is an interesting answer to our question. In the electrical world, we can read that it is therefore no surprise that the work of Professor Ferrari, when explaining rotation by alternating current in a simple language and based on principles so familiar to us, should sweep like a cyclone over all the civilized world. In this work, which made the understanding of the Tesla motor so simple, the explanation given by Mr. Tesla are as fundamental. However, there is a sufficient and distinct merit in the work of either scientist, while Professor Ferrari is the father of the electrodynamic rotation, Mr. Tesla is the father of the system of distribution by multiphase current and its application. Okay, now we can go to my personal opinion. The starting question has to be modified, changed in who discovered what. And the more reasonable answer can found only splitting and modifying the original question in two different questions. One is who discovered the rotating magnetic field, and the second is who realized the industrial induction motor. And the answer to the first question is not questionable. The theory of the rotating magnetic field was discovered and theorized from the mathematical point of view by Galileo Ferraris. The first primitive model of the induction motor has been realized by Galileo Ferraris for sure, and this discovery has been certified by IEEE in 2021 with the IEEE milestone plate to the Politecnico di Torino, and I invite you all at the end of this presentation downstairs where our rector will unveil the target by IEEE. Why the Politecnico di Torino? Because the original site of Galileo Ferraris, the lab and the office was destroyed by a bombing during the Second World War, and the Politecnico di Torino has been considered the natural replacement of the original site. Galileo Ferraris is the father of the Politecnico di Torino, so in some way IEEE recognized this point, and this is the plate, and who developed and built the first industrial induction motor. Again, the answer is not questionable. again, the industrial first induction motor was realized by Nikola Tesla, thanks to the engineering work by the company created by George Westinghouse. And here you can see again the first induction motor realized by Tesla for Westinghouse. And here you can see another motor is the Westinghouse two-phase induction motor marked M6A. And in the metal plate, we can read that the Westinghouse Electric Company, Pittsburgh 271. And this motor is in the National Museum of American History. As I said before, it is important for honesty to take into account a third person in this scientific tale, and the person is Mikhail Dobrovolsky, okay, because he was involved in the development of the industrial induction motor, because the role of Dobrovolsky is the development of the three-phase induction motor. You remember that both the model of Galileo Ferraris and the induction motor by Nikola Tesla were two-phase induction motor. The introduction of the three-phase is due to Dobrovolsky, who is he was a Russian Empire-born engineering, electrician, and inventor of Polish-Russian origin, active in the German Empire and also in Switzerland. After studying in Germany and while working in Berlin for the AEG, it became one of the founders of the polyphase electrical system, developing the three-phase electrical generator and three-phase electrical motor, and studying the star and delta connection of the motor. And the triumph of the three-phase system was displayed in Europe and at the International Electrotechnical Exhibition in 1891, where Dobrovolsky used the system to transmit electrical power for a long distance for that age, 176 kilometers, with an efficiency of 0.75. This is probably the most important point, because he created the first three-phase transformer and the first short-circuit squirrel cage induction motor. I know that he realized also the double cage rotor in order to improve the starting torque of the induction motor. Okay, now here you can see the references I used to prepare this presentation. If you go in the main page of the conference, you have to go in the bottom on the right side. You can see the face of Galileo Ferraris, and you find two buttons. In the first one, you can do the download of my presentation, and clicking on the second button, you can, the system open a page where you can find all the documents, PDF file I used for this presentation. Maybe there are 2 giga of data, but you can download the paper by paper. I apologize, but the paper by Galileo Ferraris are in Italian, but with the, I don't know, because I am not an expert, but using the artificial intelligence probably is possible to do to get the translation from Italian to English. And I wanted to highlight this link, because if you go to this link, it's possible to find all the electrical world issue, and clicking on each year, you can download the original paper scanned for the electrical world. Okay, Oh, it's very interesting. I don't remember the file, but in one of the electrical words you can find a contribution by Steinmetz where he proposed the model of the iron loss and he introduced the coefficient we call Steinmetz coefficients, and it is a very interesting contribution, original from Steinmetz. Okay, I am at the end of the presentation, but I want to use 1 minute because this is my last presentation from the academic point of view, because on the 1st of November I will be retired, and I want to thank all the friends. First, the colleague and the friends of my group. Okay, I think that I leave a very strong group in electrical machine and drives. Now there is Jimmy Pellegrino, Professor Radu Bojoi, that is leading in the best way the group. And I want also to mention the young researcher. I am very proud because, sorry, okay, I stop. Thanks. Now, I want to thank the colleague of the other university. There are a lot of colleagues here. Thanks to the IEEE Industry Application Society. I am very happy to have here the president, probably the president-elect. They are not colleagues, but I think that they are really friends. I started to collaborate with the Industry Application Society where I was young 30 years ago, and I was a reviewer, associate editor, officer of the Electrical Machine Committee, chair of the Electrical Machine Committee. I was in the board, and so I think that this was a very exciting experience from the technical, but also from the human point of view. I want to thank Professor Capolino, because he was my mentor in international activity, and I want to thank the rector of my university where I worked for 40 years. Thank you. I don't know if there is time for a question, but I repeat, I am not a historian, so I don't know if I am able to answer to the question.
Okay, the answer is yes.
It is not a question so far, but you know, Aldo is my friend for more than 30 years. I was not his mentor, it's not true at all, because we did great together, and he did great for the ICEM without any limit in time and energy. And I would like to ask you guys again to give a big round of applause for him.
Thank you, Gerard. Thank you, Aldo, also for being so generous of collecting and sharing this material. So before we all move downstairs for the ceremony, I want to recognize your special lecture with the gift dedicated to our special lecturers. So if we can have also a picture. And come. We will give you the piece of art that the people have seen already with the other speakers directly by the artist.
Thank you. an honor.
Thank you.
A prego.